Hello, students. I hope you're all well. We are going to learn chemistry together. I am going to be teaching the Edexcel chemistry for the exams of A levels. And you know that the beginning of the chemistry is very simple. It begins with the basic definitions, atoms, elements, and compounds. We know the atoms are the smallest particle of an element. An element is the simplest substance that cannot be further broken down into a simpler substance, and a compound is two or more elements chemically combined together. We know that these definitions they form the basics of chemistry. As we move on, we will be discussing more of the complex topics. And one more definition that comes into account over here is that of the molecule. So what is a molecule? A molecule is two or more atoms combined together, bonded together. So we know that most of the compounds that are formed, many of them, they are made up of molecules. And in case of the molecules, there are again different types of molecules. There are the diatomic molecule, which contain two atoms, the polyatomic molecule that contain more than two atoms, and then there are the heteroatomic molecules and the homoatomic molecules. Heteroatomic are those that contain different types of atoms, whereas homoatomic molecules are those that contain same type of atoms. Homoatomic will include atoms like P4, like only phosphorus is present in this molecule, then S8, H2, Cl2, all these we know that they contain the same type of atoms and are therefore the homoatomic. For the heteroatomic, all the other molecules ranging from the simplest such as HCl to as complex as the glucose and polymers and so on, C6H12O6, we know that there are different types of atoms that are present in such a heteroatomic molecule. Then there are the diatomic, triatomic, and polyatomic molecules that I have just told you about. Okay, students, next on we are going to be discussing uh, most of the equations, how they are balanced. It is quite simple to balance equations, and when we start the discussion about balancing the equations, we usually start with the simplest ones, of course, first to give you the concept, balancing the equations. If we have this equation, like the hydrogen is going to combine with oxygen and it forms H2O, we first of all need to balance the atoms that are present on the product side with that of the reactant side. So H2 is already H is already balanced, a hydrogen, but the oxygen is not balanced. When we put a 2 over here, in order to balance the oxygen, we disturb the hydrogen number as well. Now we have 4 hydrogen over here, and therefore we need to put a 2 over here in order to balance this. Now this is easy. This is one of the simplest ways. However, when we are to balance bigger equations, more complex equations like that of combustion, it becomes a bit difficult. So I'm writing down an equation over here, C4H10 oxygen, and it is always going to produce, if it's complete combustion, it's always going to produce carbon dioxide and water. So we have to now balance this equation. For that purpose, I start with the carbon. If I put a 4 over here, and we have balanced the carbons. Now, in such types of equations, I always suggest that you do not balance oxygen first. You keep oxygen for the last. So we have balanced the carbon. Now we go on to balance the hydrogen. So here we have 10, here we have 2. If I just put it 5 over here, we have now balanced the hydrogen. As for the oxygen, on the product side, let's count the number of oxygen. Protons are 8 plus 5, so we have 13 oxygen over here. And on the reactant side, we have just 2. So in order to make it 13, what are we supposed to do? So we can do multiple ways. We can go on to find different approaches over here. First of all, one way is that we multiply it with the 13 by 2. If you do that, 2 is cut with 2, and we now know that there are 13 oxygen on the reactant side. This can be done. Also, instead of placing 13 by 2, we can place 7.5 here as well. That too, like we know that 13 by 2 equals 7.5. So 7.5 can be placed over here as well. Or what we can do is that instead of writing 7.5 or 13 by 2, we write a 13 by 2 and then multiply this entire equation by a 2. When we do that, the balancing is going to look something like this. CO2 plus H2O. We get a 2 over here, a 13 over here, an 8 here, and a 10 over here. The 2 is going to get cut with this 2, 13 by 2 multiplied by 2, 2 cuts with 2, and we have the 13 whole number. So that's how you can also balance this equation. Now, there are certain equations when writing down the symbols is very important. For example, in this case, it might not be that important, but there are other cases where it is very much important. In combustion equations, it isn't, however, necessary. But just to make sure that you know these symbols, I'm going to write them over here. So C4H10, which is a butane, it exists as a gas at room temperature. Oxygen is also a gas. The production of carbon dioxide will occur in the gaseous state. And since this reaction is occurring at a very high temperature, the water that is produced won't be a liquid. Instead, it will be produced in the vapor form. So all the products and the reactants over here are in their gaseous state. Now there needs to be a discussion of these arrows as well. So you might have seen arrows that look like this, or there may be another type of arrows that look like this. So these two arrows may be used within the chemical equations. This type of arrow shows that it is an irreversible reaction. The products cannot again combine to form the reactants. This is, on the other hand, a reversible reaction. So the products can, in the case of reversible reaction, the product can recombine to form the reactants. And most of the times, the reversible reactions are those that are taking place within a solution and in which we have some ions that are breaking apart and they're combining again. This completes our topic of balancing the equations. Next on, we are going to start with the typical reactions. So in this topic, we are specifically going to discuss the reactions of acids. So acids, they give plenty of reactions, and the topmost in them are the reactions with metals, with bases, otherwise known as the alkali, with metal oxides, with hydroxides, metal hydroxides as well, with carbonates, and with hydrogen carbonates as well. Okay, so that would be it for our today's lesson. In the next lesson, we are going to study all these reactions in detail.